Example 1. A local convenience store owner spent $10 on 144 pencils to resell at the store. What is the equation for the store's profit if each pencil sells for 50 cents? Graph the equation using a table of values. So let's begin with our knowns. We know that profit is going to equal revenue minus cost. Revenue is the amount that he's going to bring in from selling the pencils at 50 cents a piece. So our initial cost was equal to $10, and the revenue is going to be 50 cents per each pencil. Let's substitute that back in for profit, and we can use y for profit. So let's use profit is equal to y on our axis. So we have y is equal to 0.5x minus the initial cost of $10. Let's create a table of values. X will never be negative in this case because we never have a negative number of pencils. However, our y can be positive because if we don't sell any pencils, the store owner will be out $10. He'll have a negative $10. If the store sells 10 pencils, the store owner will have lost $5. At 20 pencils, he finally breaks even, and he will neither have a gain or a loss. At 30 pencils, the store will have earned $5. And at 40 pencils, the store will have earned $10. Let's plot these sets of coordinates on the graph. Let's begin by labeling our graph. On the y-axis, we have profit in dollars, and along the x-axis, we have number of pencils sold. When the store has sold 0 pencils, there is a loss of $10. When the store has sold 10 pencils, there is a loss of $5. When the store has sold 20 pencils, there is neither a gain or a loss for the store. In other words, y is equal to 0. Let's connect these coordinates. Let's connect these coordinate pairs. We could also label some of the coordinates on there if we'd like to. So this would have been, this first point is 0, negative 10. The second point is 10, negative 5. And the third point here is 20, 0. Let's connect these points. And I'm going to point to my line. I'm going to write down the equation for it. Y is equal to 0.5x minus 10. Example 2. A taxi company in Kansas City charges $2.50 per ride plus $2 for every mile driven. Write and graph the equation that models the cost of a taxi ride. Use the slope and y-intercept to draw the graph. So once again, let's start off with our knowns. We know that the initial cost of just sitting in the taxi, not even driving anywhere, just for hopping in the cab, would be $2.50. We also know that it's going to be $2 per mile. So $2 per mile. So m, our slope, is going to be 2, because it's $2. I'll put $2. Put our units on there. Per mile. So our equation for our cost of the ride would be y equals 2x plus 250. Let's create a table of values. Let's plot these coordinate pairs on our graph. Labeling our graph first with cost in dollars along the y-axis and distance traveled miles along the x-axis. So at 0 miles driven, our y-intercept is $2.50. At 1 mile, the cost is $4.50. At 2 miles, it is $6.50. And at 3 miles, it is $8.50. Let's go ahead and connect these coordinates. And I am going to label my line as the equation y is equal to 2x plus 250. Taking a look at our graph, we can also confirm our slope was equal to 2. So in other words, I'm going to go up 2 vertically for every 1 over horizontally. Example 3. Miranda gets paid $300 each week to deliver groceries. She also earns 5% commission on the total cost of each order she delivers. Write an equation that represents her weekly pay and then graph the equation. So let's once again begin with our equation. Y is equal to mx plus b. B is her constant. She is going to earn $300 a week at the grocery store. And she's going to earn an additional, so her slope is going to be 5% commission on the total cost. Let's think about this 5%. That means 5 out of 100, which is equivalent to 0.05. So our equation becomes y is equal to 0.05 times x, x being the total cost of each order she delivers, plus the $300. Let's create a table of values. If Miranda doesn't sell any groceries that week, in other words, 0 for x, then the amount of her weekly pay would just be $300. If she sells $100 in groceries, substitute 100 in for x, she would earn $305. At $500 of groceries sold. If our input is 500, our output would equal 25 plus 300, so she would earn $325. How about at 1,000? So she sells $1,000 in groceries. She would earn 1,000 times 0.05, which is $50, plus the 300, so $350. Let's go ahead and plot these coordinate pairs, beginning by labeling our graph along the y-axis with the weekly earnings in dollars, and along the x-axis, the orders in dollars. So our y-intercept here would be 0, 300. That is if she does not sell any groceries at all. At 100, we'd have 305. At 500, we have 325. And at 1,000, we have 350. Let's connect these coordinate pairs. Let's label our line with the equation y equals 0.05x plus 300. We could also confirm our slope by doing our rise over our run. Our rise being $25, our run being $500. 25 divided by 500 is equal to the 5%. Example 4. The velocity of a ball thrown directly upward can be modeled with the following equation. V is equal to a negative gt plus v subscript 0, where v is the velocity, g is the acceleration due to gravity, t is the elapsed time, and VO is the initial velocity at time equals 0. If the acceleration due to gravity is equal to 32 feet per second, and the initial velocity of the ball is 96 feet per second, what is the equation that represents the velocity of the ball? And graph the equation. So let's begin with our initial equation of v is equal to a negative gt plus vo. Let's go ahead and substitute y in for v. So v is our velocity. And let's substitute m. Our slope is equal to a negative g, which is equal to a negative 32 feet per second squared. Let's let the variable t, time, equal the variable x. And our initial velocity, VO, is equal to 96 feet per second. Let's put this equation into y equals mx plus b format. So we would have y equals a negative 32x plus 96. Let's make a table of values. So at time 0, the ball is traveling at 96 feet per second. At 1 second, it's traveling 64. At 2 seconds, it's traveling 32 feet per second. At 3 seconds, it is traveling at 0, a velocity of 0 feet per second. 4 seconds, it's a negative 32 feet per second. At 5 seconds, it's a negative 64. Let's go ahead and graph these coordinates. So to begin with, our y-intercept is 96, 0, 96. We start off at 96 feet per second. After 1 second, we're at 64. 2 seconds, we're at 32. 3 seconds, 0, a velocity of 0. 4 seconds, a negative 32. And at 5 seconds, we have 64. Let's go ahead and connect these coordinates. And let's label our line as y equals negative 32x plus 96. If we want to use our original variables, we would have v is equal to a negative gt plus v0. Let's think about this. At time is 0. Let's make a little timeline here. The ball is traveling up. And at a certain point, the ball begins to come back down. So where did that occur? At velocity is equal to 0. So that would occur at 3 seconds. So we have a positive velocity for the first 3 seconds, and then a negative velocity after 3 seconds as the ball travels back down to Earth.